we're recording, share my screen, don't want to forget that, and there we go. Okay, so yeah, week 14 posted up here on our GitHub repo. And this week, so not the last week of the semester, but we will be doing our sort of like last week of the semester this week, so that all of you seniors can graduate and go on to live even better, more productive lives than you currently are. But so for the final exam, totally done with material. Just sort of review this week today, like my version of the review, things that I want to highlight just at the end of the course. And then Wednesday, I'm not going to have anything prepared for Wednesday. It'll just be a chance to ask questions about whatever it is you want to ask questions about for preparing for the final exam. And then Friday, no class. I'll post the midterm. And later on today, we'll talk about the exact format of the midterm, but you'll have the weekend and then into Monday to complete it. And that'll be the last thing for all of the graduating students. Next week, the non-graduating students, one last topic for final homework assignments. Any questions about anything administrative for reviewing? Okay. So the main things that I want to review today are the sort of things that you should kind of keep in your back pocket for when you're in an interview or talking to people about technical things, and the key sort of highlights that you should be able to talk about, and or if you're talking with a manager, being able to convince your manager that going down one path is the right way to do it instead of another path. So the first thing in this course that we talked about is the idea of DevOps, standing for developer operations, kind of sitting at the interface between writing code and just managing hardware. And the first main life pro tip I have, using Linux for everything. If even Microsoft uses Linux more than Windows, which this link right here talks about, then you should probably be using Linux if Microsoft thinks that Linux is better than Windows. And here's just a famous fun tweet that tell us you're a developer without telling us you're a developer, and reply, I'm using Linux. In addition to Linux, so containers, again, what's the big idea of containers? So all of your infrastructure is in a config file, so you can put it into Git, store it on GitHub. Doesn't matter what kind of natural disaster you face, you can always be able to just download, reclone your repo, restart your projects. So it really simplifies and automates the deployment of your techs, of your technologies. You can run it locally or in the cloud, all the same techniques. Again, we didn't really run anything directly in the cloud, but it's just the different command line parameters to Docker that specifies your AWS passwords or your Google Cloud passwords. And if you do things in Docker in containers instead of directly with the vendor, no vendor lock-in, you can always just go to whatever's cheapest. And there are things much, much cheaper than AWS. Everybody uses AWS just because that's what everybody's heard of, but many other things much cheaper. So we used Docker and Docker Compose. Other technologies, Kubernetes is the main one. This comes out of Google. It's abbreviated K8s. Took me a long time to sort of understand why it's abbreviated this way. But there's a lot of abbreviations in computer science that look like one letter and then a number and then another letter. And what that is it's the first letter of the word, then the number of letters between the first letter and the last letter and the last letter. So anytime you see an abbreviation like this, that's how they get it. Kubernetes is like Docker, but really more like Docker Compose, but even more advanced, lots more configuration options, and so that's what Google uses internally at scale. If you're really interested, it's actually not too hard to do Docker containers from scratch without using Docker, just in Bash, and that would be a cool thing to do, but not something you're required to do. Other sort of life pro tip, so using a good text editor, I use Vim for everything. If I haven't convinced you to use Vim for everything, then whatever you do use, you should just get good at it. And I can pretty much like tell whether I'm going to I'll phrase that differently. Pretty much every developer is going to, like, in the first 5 minutes of working with somebody else, get a sense of like how that other person works. And one of the main things that's going to jump out to people is how well they use the tools that they're working with. And so if you want to be like leaving a good impression when you're interviewing people, like, or interviewing with people, working with them on your laptop, showing them how you use your tools, then you want to actually use your tools well, whatever they are. Version control, I do everything inside of Git. So literally, like, every document that I've ever written in the past 10 years is inside of a Git repository. Makes it really easy for me to be confident that if somebody came and stole my laptop or smashed it with a hammer, I'm not going to lose anything. And if I needed to go back, figure out my taxes from 5 years ago, that's just a Git checkout to the 2015 or whenever I want to look at it and get that information. And so, yeah, the more you use Git, the more you use Vim, the better you'll get at them, the better you'll get at coding, sort of even when you're not doing coding stuff. Last sort of major life pro tip, test cases for everything, continuous integration for everything. So things like GitHub Actions, they make it free. So you may as well use it for all your projects. One of the things that's like students often say is that I don't want to put my stuff on GitHub yet because it's not ready. Nobody is ever going to like look at a repo on GitHub and say, oh, this sucks, I'm not going to want to work with that person. The only thing that anybody will ever say is, oh, this is cool, I do want to work with that person. If they see something that sucks, they'll just forget about it and move on. So yeah, everything on GitHub, don't worry about it. Take advantage of all these resources that people are giving you.
Professor, I have a question.
Yeah, go ahead.
For the GitHub action, I don't know how it works really. I just know that we use it to like test our test cases, but I never like thought about it.
Yeah, so the question is that in this class, I gave you all of the like systems for using GitHub Actions and didn't make you write your own GitHub Actions at any point. And so how do those actually work? That would be sort of, I'd be happy to help people figure out on your own personal projects doing things like that. And that'd be a good thing to do so that you can do it on your personal projects. One of the sort of tensions that there is in all of these courses is like, what are the good things that people should know and how do you actually evaluate students on those things? And there's really no way to like assess whether somebody's created good GitHub Actions or not. So that's why there's no assignments on creating GitHub Actions, even though that would be a really good thing to have assignments on. Yeah, that's a good question. Again, if other people have questions about anything as we're going through this, feel free to shout out and ask them. The trade-offs with GitHub Actions, again, so the big data sets make it harder. We saw that with the Twitter indexes assignment. That was the one that we couldn't do the GitHub Actions on, but we sort of structured the Twitter assignments in such a way so that we could use GitHub Actions on the smaller data sets, making sure everything's correct, and then just generalizing to the large data set once we're done with that. Yeah, so I don't know, I'm not going to read through the whole comic here, but the idea of the comic is that this guy right here is the bad guy that you don't want to be working with because he's not writing the test cases, and so everybody else gets mad at him when he submits code and there's bugs. Other sort of takeaways, so all of this DevOps stuff is super hard. It's not going to be on the final at all, but it's been incorporated in various ways into your different projects. And this came up just over this weekend with this issue 184 on the search engine. Over the weekend, or maybe like Thursday or Friday at some point, the search engine assignment stopped working because of some I don't know, changes that people made at random spots online that I don't even know what exactly they made. I fixed that now. But this idea or this like dream that Docker is going to make everything just like work and you never have to fix things doesn't actually manifest itself that way in practice. You do have to revisit these Docker containers and fix them occasionally. And that's just huge, super painful work. One of the main, so at the very beginning of this class, we did the MapReduce assignments. And when people think of like big data, that's often probably the first thing that they think of, MapReduce. And when you think of big data, when you think of MapReduce, when you're talking about it, either in interviews or to your coworkers, the thing you should think about it for is like one-off tasks, things that you're never going to need to repeat again. Reason for that is because it's easier to set up than a database. There's like no setup. It's sort of trivial to set up. But it takes a little while to repeat or to do your work, hours for multi-terabyte data on something like the Lambda server. But so yeah, not good for like a web page where you need real-time access, but good enough for one-off tasks. We used plain old bash scripts, so like relying on vertical scaling with the Lambda server. Again, super easy to implement. I would use this sort of strategy for anything, say less than a petabyte or so, but definitely suitable for things more than a terabyte. The assignment you did was for more than a terabyte. And the reason that I would use this is it's just the same, like, well, it's super simple to use, but even if you had to use a different technique, the idea of having just like a map file that computes things on one file at a time, and then joining those things together is the basic idea that all of these other MapReduce technologies use as well. These ones down here use the horizontal scaling, so multiple computers instead of the vertical scaling. But again, the sort of price range that you're talking about in terms of like cloud computing resources or any sort of resources, it's going to be about 10 times more just dollar-wise to use any of these products than to use plain old bash scripts. And so unless you're really in the multiple petabyte range where you need to do this stuff, I would recommend not doing it. And even honestly, in the multiple petabyte range, I would do bash scripts on multiple computers. The reason that I like bash scripts so much is that they have lots of applications that if you get good at bash scripting, you're going to make everything in your life easier. I write bash scripts probably at least once a week for automating different things in my life. Hadoop, if you get good at that or any of these other sort of standard MapReduce tasks, then you'll only be getting better at MapReduce tasks and not at other things. But if you get good at bash, you're getting good at MapReduce and everything else as well. So one of the sort of general principles of being a good programmer, be as lazy as possible, get your like general tools that do everything. So bash is probably the #1 tool along those lines. And then you don't have to do all of the like overhead of installing all those other tools because bash is everywhere. The other main tool, so databases, that's what we spent most of this class on because it's a lot more complicated. And here I put it for like big-ish data, so up to petabytes. I would call that big-ish data. Facebook would still be calling petabytes small data. But unless you have a good reason not to use a database in your application, you basically always want to use your database. Very rarely do I store things in just like a text file or a flat file like that. It's always going into a database somehow because databases have those ACID guarantees. So much, you get so much stuff for free. The really big data, like we saw, so things like Common Crawl Internet Archive, they'll develop their own custom formats, but you're probably not going to be in that situation, and so you should probably just use Postgres. Reason people like Postgres these days, so again, correctness matters, and Postgres' #1 priority is correctness. So correctness here means not losing your data, that if you put data in, it's guaranteed to be there. If you insert data, it will be there. Famous stories, lots of famous stories of things like MongoDB or other NoSQL databases losing data. And so The Guardian, major newspaper, had articles stored in MongoDB, randomly lost a bunch of articles, and so they switched over to Postgres because of that. can find lots of similar stories online. And this, again, is the sort of story that you want to be able to pull out of your back pocket if you want to convince like your managers or coworkers to go with Postgres. People will talk about like Mongo or these other ones being faster, and so they're better for that reason. Really, at least in my view, computers are fast enough these days that Postgres is nearly as fast as these other systems, like factor of 2. And if you really needed to get even faster, you can turn off those safety guarantees that Postgres gets you to get faster. But you don't want to do that. The tagline of Postgres: world's most advanced open source database. New features constantly being added. So they pioneered the addition of JSON to RDBMSs, things like Oracle, MySQL. None of those had JSON support before Postgres. No, there are no databases that are fully compliant with the SQL standard, but Postgres is more compliant than the other databases. And people do use Postgres on multi-petabyte data sets. A lot of those videos, like the state of the industry videos about how to do that, how people are doing that. Again, extremely popular in industry. If you haven't seen these articles before, oops, refresh that real quick. It's the April one, this month. So if you haven't seen these sort of like Ask Hacker News, who's hiring, these are mostly not for like junior people like you'd be maybe applying for jobs, more senior roles. But if you just do a search down here for Postgres, 40 different matches, 40 different companies looking for Postgres developers. If we're looking for like MySQL, 6 matches. If we're looking for Mongo, 14 matches. Talked about things like Elasticsearch a little bit, 9 matches. So Postgres is, at least among the cool kids, like really the database that, that people are using these days. Again, this like stackshare.io website, a good way to see what companies are using different products. So here I'm on the Postgres page. All sorts of major companies that you've heard of probably use using Postgres behind the scenes to store all their data. If there's another like technology that you've heard of that you want to see like what people are using it for, then this is just a good way of figuring out, okay, MongoDB, who's using MongoDB? Or something else that you've heard of before, you can type it in and it'll tell you what companies are using those behind the hood. If there's particular companies that you're interested in, maybe you're going on an interview with those companies, then those companies also have individual pages on the stackshare.io webpage. And so I would never go on an interview with a company without first looking up what tech stack they're using, so I can talk to them, ask intelligent questions about like what products I would be working on, and show off my knowledge about various products. So you can, again, yeah, go to that Stackshare, look up the company, and find the details on their stack that way. Again, Postgres, it's good enough for Instagram. You're probably not going to have bigger data than Instagram, so it's probably going to be good enough for you. And again, just like Microsoft prefers Linux to Windows, even Microsoft prefers Postgres to SQL Server, their database offering, when they actually need to do large-scale data analysis. So here's just a blog post from Microsoft.com about why they chose to use Postgres for certain tasks instead of their own offering. One of the main things that we talked about in this class about normalization and dealing with the normalized versus the denormalized data. If this were like an actual database class, we would have spent time on like what are called normalization forms and talking about those in detail. But really the key idea, the thing that people care about in practice, is that normalization is just sort of the spectrum of things that are more normalized, have these sorts of properties. You have more joins, easier to do selects from, use less disk space, and but it's harder to do the inserts on. And then the denormalized data, easy to insert, JSON being like the most fully denormalized thing. Everything's just in one table. but it uses more disk space, lots of weird syntax on your selects, and but no joins, so potentially faster. My heuristic for like how you should design things is that if you're responsible for the data, you should prefer the normalized because you get a lot of correctness guarantees. But if somebody else owns the data, then prefer the denormalized because it's just easier to work with. On your final exam, there's the final exam questions are going to be more like actual technically focused, sort of true or false question or questions with an exact answer. And for like the normalization, there's rarely an exact answer of like what is the exact best thing to do here. Coming up with a good database schema to hold your data is definitely an art that takes a lot of practice, and that's why CTOs get paid a lot of money. That's like their main responsibility, is getting that database schema set up correctly. So using indexes, talk about the main purpose of that, making selects faster. This is again starting to get into like what's really going to be the hard stuff, the main body of your final exam about the indexes. Lack of indexes makes lots of bad things happen. Here's an example of a company just being brought down off the internet because of an index that they forgot to build. Your inserts, so the main trade-off, select faster, insert slower. But the insert goes from constant to logarithmic, so it's really not that much slower. Select goes from linear to logarithmic, so huge, huge speed up. There's lots and lots of types of indexes. We covered these 4 types in class. Again, anytime you see anything like full text search, JSON, or arrays, you should be thinking GIN and RUM index, and everything else thinking of B-tree. But you don't want to use a hash index. Potentially, they can reduce the number of pages accessed by like 1 or 2 compared to a B-tree index, but so many more limitations. So nobody ever uses a hash index in practice. We did not cover some other index types, but you will be responsible on the final exam, especially in, there's going to be a true and false section. You will be responsible for being able to look up information about these indexes and in the documentation. And so yeah, so you will have to know something about them. In terms of like, in general, what indexes are supported in databases, these indexes all have slightly different names in other databases. Minor implementation details different, but these are really like all the indexes that exist, like in principle. And there's nothing else that, that can exist that doesn't exist in Postgres. When you're creating your queries, general procedure, so that's sort of what you did on the last homework assignment, sort of first focus, making sure your select statement is correct, then make it fast. Sometimes you'll need to rewrite your select statement to use the indexes better. Probably didn't have to do that on the homework assignment. This is usually something that only comes up when you're into like, I don't know, 50, 100 line long SQL queries, things that we didn't get to in this class too much, at least in the performance part. Things that we did talk about though, removing set returning functions, you can't speed those up. Adding the limit clauses, only in certain situations. This will be a big, this will definitely come up, I don't know, it's probably like 10% of your final exam is figuring out when the limit clauses will speed up your queries versus not speed them up. Remember that one of the main advantages of the RUM index over the GIN index is the RUM index, you can do the index scan. GIN index, you can only do the bitmap scan. And so the GIN index, you can't speed up the limit clauses. It's one of the main things to remember about the GIN versus the RUM index. But there are lots and lots of other tricks that people use to make things faster. And again, we didn't cover them all, but one of the things that sort of separates a good from a great junior developer is sort of going out of your way to find these sorts of articles and learning these tricks on how to speed up your queries. Other technologies, things we didn't cover. So anytime you see the RDBMS, the R standing for relational, these are all the ACID guarantee databases. NoSQL, no ACID guarantees. These come in a couple of different flavors. The main one, most popular, JSON denormalized representations, MongoDB being the main example of that. Super popular around 2010. Popularity, I don't know, they're still very popular, but I think they're declining very rapidly because of people realizing the ACID guarantee is actually really good thing to have. And today, Postgres supports everything that things like MongoDB do, but they also support more. So you may as well just use Postgres. Talked a little bit about full text search. Not as much as I probably would have liked, but this is getting into one of my like actual research areas, full text search. The main thing though that we talked about, there's these competitors to Postgres, and at this point they are better than Postgres, but my prediction is that just like Postgres, after 10 years or so, beats out all the JSON competitors in NoSQL. I think 10 years from now, Postgres will be state of the art for full text search. And there's other types of things too, like cache databases and many other types of database technologies too. But sort of the trend that people are recognizing is that, yeah, so you're junior dev, you start with Postgres. As you get more and more experience, you're learning these other technologies, you start adding them into your tech stack. But like the most experienced developer realize this is way too complicated. All these other things aren't giving you other features that Postgres can do. So you may as well just use Postgres for everything. Simplify it and be just as good. Dustin?
I never was quite sure why MongoDB has no guarantee that the data will be.
Yeah, question is, why does MongoDB have no guarantee that the data will be inserted? The answer is that, so it's a complicated technical answer, but if you remember how Postgres, we talked about there's all of this overhead, about the 24 byte overhead per row, and it's divided into these 8-page chunks. MongoDB, in order to be more efficient, doesn't do that, doesn't have basically any overhead, doesn't divide things up into these pages. And so when there is, say, like an update on some of your data, it doesn't know necessarily how to block other updates so that they don't conflict with each other. And so if you have 2 updates going on at the same time, which one's going to happen? Who knows? There's no way to guarantee that like a transaction is going to be atomic, or if we do an update and then the system crashes before the transaction completes, it's not going to be able to roll back the same way that Postgres does. So because it doesn't have those sorts of features, it can be faster, but yeah, it's those underlying technical details that we really only scratch the surface of. That's what makes Postgres better than that, in that way.
Are there like particular reasons people use like MongoDB then? So like why people use AWS? It's just like mix of advertising and think other people use them.
So the question is like, so then why do people use MongoDB? My impression is that like if it were 2010 right now, then MongoDB would be the thing to use for a lot of use cases. Like if you really just have JSON data, then MongoDB is the only thing that supports that in 2010. And so because of that, Mongo became super popular at that point, solved a lot of business problems, and is a legitimately good database for that use case. Postgres realized that a lot of people were turning away from Postgres to go to Mongo, and so they said, okay, let's just implement all the features that Mongo has. And now that they've done that, I don't see any reason to use Mongo instead. At this point, say it again? I'd say like the reason people are turning to it is just because of legacy reasons that other people have turned to it. Or maybe I was coming of age as a developer in 2010, and so I know how to use MongoDB really well. And so when I'm starting a new company in 2022, that's what I'm going to turn to. I wouldn't say that it's legacy in the sense that like it's still fully supported. The Mongo company is, I don't know, pretty sure if they're not multi-billion-dollar market cap, they're close to that. And it's not going away anytime soon. So yeah, not legacy in that sense, like Windows 95 is a legacy program, but not what I would turn to. And probably like, I know there are people who would disagree with me on that. I'm very strongly in the RDB mess camp, very strongly in the case of like my data matters and I will sacrifice speed in order to have correctness. But if your data is like how many times people have clicked a like button on a web page, your data doesn't matter, and so maybe MongoDB is actually the thing to use. Yeah, those are all good questions. Any other questions sort of on that topic? Maybe, yeah. So my sense too is that, I don't know, the computer programming sort of world is very faddish, and there are like technical things that will ground those fads in reality, but exactly what's popular at any given time almost rarely has no like technical basis, and just due to various fads and popularity reasons. But one thing super important to notice is that all of those technologies, Mongo, Postgres, anything else that I mentioned, all of them are open source, and technology is not what like differentiates one company from another. It's all the data and how that data is deployed and what they're doing with it. So the data is what companies actually value, not their tech stacks. Maybe last note here on, before we get to the final, of some things to make sure that you don't do. The main one, I guess, take away from this class, don't use MapReduce when a database is more appropriate and vice versa. So MapReduce, summary again, one-off analysis tasks that take a long time, but that there's no setup overhead, so it's nice and easy to do. The database, we saw that there's a lot of stuff that goes into that. Takes a lot of setup with Docker and actually defining your schemas, getting the data in. That's a huge pain in the butt to do all that. But once you do that, you get like actual real-time responses to your queries, sub-millisecond responses. And so if you need things actually to be fast, do it in the database. Or if you need things to actually be like correct the ground truth storage for your data with lots of updates, inserts, deletes, do it in a database. Otherwise, use MapReduce. And when interviewing, there's a good sort of like distinction. If people are talking about big data, there's a good distinction to like make sure that you emphasize with your future coworkers. And especially talking about the Twitter assignment, I think most graduating undergraduates on their first jobs will not really have very much experience like with this sort of trade-off. And I've really tried to design these assignments so that it gives you cool things to talk about in your interviews. So actually, like, mentioning all the different things you've done with multiple terabytes of data and observing these trade-offs in practice is a good thing to bring up. Another thing don't do, so don't upload your credentials to GitHub. Don't upload your passwords to GitHub. Sounds like a stupid thing to do, but people do it all the time, and that's how companies lose millions of dollars, get taken over by hackers. So make sure you don't do that. Last thing, getting into good habits as a developer is another one of the, I know in the first, usually like, maybe not like the 5 minutes when I first meet somebody, but the first time that I like evaluate their code and sit down and really work with somebody in detail, I can get a sense of what kind of habits that person has. And one of the habits working in a database that you really want to make sure you have is that anytime you're modifying the database, you always do that in a transaction, so that if you do something stupid, you can roll back the transaction. If you're not in a transaction, then whatever you do is going to be permanent. You can't undo it. So just being in the habit of always getting into a transaction is a good thing, good habit to be in. A few other last notes. So academic versus industry big data. This class mostly focused on industry related things, actually getting things up to speed. Academic big data. So if you were to do like grad school stuff related to big data, much more math heavy. These are all things that if I had maybe 2 or 3 more weeks in the course, we would cover all these things because I really like them. They'd be good things to, I don't know, maybe look at on your own if you want more big data in your life. This CAP theorem especially, and hyperlog things that you'll see people talk about all the time. So good things to look up. And related to that, where to go from here in your life. Learning more math, always good. Learning more technologies, pretty much always bad, at least in my opinion. The technologies, it's all like fads, so they'll go out of style. Just putting them on your resume, like nobody cares. Whatever company you go to, there's going to be new technologies there that you'll have to learn. There's just too many things. We saw this big data or Pokemon game a while back, and there's just, too many technologies. So you can't learn them all. Don't try. Instead, just building stuff. I can't think of a single type of like web page or data analysis tool that you can't build with the tech stack that we did in this class: Docker, Nginx, Gunicorn, Flask, and so on. I'm sure there are some, but again, this is what Instagram uses, and so if you can, you're probably not going to scale past Instagram. If you do, then congratulations. But if there are other things that you need to learn it as you need it, and again, much better to be an expert in a small number of techs, especially as a junior dev, because people just want to see that you're able to have some sort of expertise. And exactly what technology it's in doesn't matter so much, because again, the technologies will be almost guaranteed to be at least a little bit different in your company. They just want to make sure that you can be an expert. So much better to actually build a product that people can use and see. So again, this comic here, I won't read off the whole details, but this guy's actually building something cool, and then the guy in the background is just making fun of him for not using the latest technologies, and he never actually gets something built, but this guy actually does get something built. And so you want to be like this guy in this comic. And then the last thing, so things that will make you more productive in the future: Bash, Postgres, Vim, guaranteed to have lots of good applications in the future. So I would do lots of this stuff. And anything else that I can help you with in the future, definitely please feel free reach out and ask, and I would be more than happy to help any of you with anything that I can. Okay. Talk about grades, last grade stuff, and the final exam next. Any other questions about anything before that, though?
Yeah, I just saw in the comments something about Microsoft services and monolithic app thing, and I was wondering what you think about that.
Like a monolithic app versus microservices? Is
that? There's something that you said.
Yeah, so one of the cool trendy things these days is what's called microservices. And the rough idea of a microservice-based architecture is that in your, you would have a Docker Compose file basically for, or a Docker file for every function that you would be writing a library for. And so you might have like 1,000 Docker files in your web page. There's lots of microservice-based architectures, but the main one that I can think of right now is Netflix. They're really famous for lots of microservices. Monolithic apps are more the style of what we've been working on, where you have just like one main database Docker file, one main web page Docker file. And the main trade-offs between the two of them are, or the reason that people go with microservices is it makes it easier for like teams to coordinate with each other. And so like at Netflix scale, you have, I don't know how many thousands of engineers they have. Nobody knows everybody else's team. And so you need to have very clearly defined interfaces between like one person's product and another, and putting those in Docker files tends to make things easier. So I guess my thought on that is that it's not like a strictly technical decision. It's where the technical meets the like people aspect of things. Larger company probably, well, if you have a very large company that's very new, so Netflix sitting in that category in my mind, that would be in the like microservices, going microservices route. If you have an older company, so like Facebook, Google being old companies in this context, they all have monolithic sort of architectures, Instagram monolithic. And if I were just like starting a startup, like at this point, I'd definitely be starting out monolithic just because it's easier to get started with. And then maybe once I hit like the 100 to 500 engineers mark, I would be thinking about transferring over to something that was more microservice-ish. But that's also not things that I've ever actually done before, so you should take my thoughts on that with a huge grain of salt. And I'm just getting that sense out of the people I trust who have done those things before. Any other questions? That was a good question.
Not sure if this is, or like how this is going to actually be here, but Google claims that they have the entire, like everything that they make in one repository. So like one on a report and not just the.
Yeah, so this is a slight distinction between so monolithic app versus monolithic repository. Facebook and Google both famous for having monolithic repositories. And so that means basically one Git repository with all of Google inside of it. And when they say things like that, they have a lot of these like submodules inside of them. So like all of our homeworks have been submodules inside of the class repo. Let's see. I used to know a lot more about the internals of how Facebook and Google structured that, but I don't remember any of those details. Yeah, again, so I guess if I were starting a company, well, the main advantage of doing it that way with like a monolithic repository is that, and this has happened before at both Google and Facebook, but like a disaster has happened and they have to restart every computer in their servers. How do you actually get your system back up and running? If you have things in just one repository, there's just one command that you have to type build, and it'll download everything, do everything, bring everything back up online. Might take days or weeks for that to happen because there's a lot of stuff at Google. But if you have things in like many smaller repositories, it's generally easier to work on like one small product at a time. But then like disaster happens, you have to bring everything back up. There's no like one source of truth on how to do that. And you have to, I don't know, in people's memories somewhere, what's the right order to run different commands.
So you're saying that they have different repositories, but they have like one that's the big repository that has the other submodules.
Yeah, so like at Facebook, for example, Facebook develops React, and React on GitHub has its own like repository, and so on the Facebook repository, that React repository is like a dependency of it. So even though Facebook, we say it has a monorepo, there, like React, you could think of it as its own separate repository, but it's kind of like a sub-repository of the main one. Yeah, things that don't have a monorepo, they'd be like more side-by-side, kind of what the repositories are. Sort of like a repository for each Docker service, maybe, thinking of it something like that. I don't know, does that sort of address your question?
Yeah, yeah. Thank you.
Any other questions or thoughts people have? Okay, so last grade things. Everything in Sakai is up to date, so you should know exactly what your grade is going into the final. Just remember that we still have these 2 caveat tasks. Not very many people have completed either of them. And if you don't complete them by the time they are due for you, it will result in the loss of a letter grade, each one. So if you have an A right now and you don't complete either of them, then the highest grade that you can get in the class is a C. So I really don't want to have to do that to anybody, so please make sure that you complete these tasks. And graduating students, you have 1 week from today to complete those. You also have this sort of the state of the industry videos, a handful of videos to watch to see like what people are actually doing. I think actually some of these videos will touch on those sort of like monolithic architecture and monorepo ideas at different companies. But they're mostly focused on the things like that directly talked about in this class. For the final, again, I'll post it this coming Friday morning. So no class this Friday. And you'll have until Monday midnight to complete it. So I wanted it to be that you didn't have to work on it over the weekend. If you don't want to, you could just do either Friday or either Monday. Hopefully that will give you some flexibility with, I know there's a lot of other work going on right now with other finals and whatnot. 120 points total. Currently have about 240-ish points in the class. Again, slightly different for everybody, but it'll be about a third of your final grade. Formats, take home, same rules as the midterm, open notes, open internet, open anything written before the beginning of the exam. You can use Postgres and Lambda server. Feel free to do anything you want on those. The only requirement is no communication with any other human being. Mainly because of this requirement right here, there's not going to be any questions on the blocks, locks, deadlocks portion of the class because you could just type that all in directly, so we won't test that. Yeah, so 60 points in true and false questions. That will probably be, I haven't decided yet if it's going to be 20 questions, 3 points each, or 30 questions, 2 points each. But a fair number of true-false questions that cover anything, pretty much anything's fair game, but you have lots of sample questions from the handouts. That'll all be from the second half of this course. And again, about half the questions covering material like directly from lecture and assignments, and half will force you to look up things in the references. And then the other half of the exam, free response, basically the same format as the indexes quiz that we went over before. Any questions on the final exam, what to expect?
Maybe go over exactly study. Like, what did you just go through a lot of the GitHub pages and then also the wire documents?
Yeah, good question. Questions like, what's the best way to study for the exam? What you want to make sure is that any questions that you might have that you would want to ask me, make sure that you're able to like find those questions and get them asked before the exam starts, because I won't be able to answer the questions after the exam. So any of the questions from the handouts from the past month or so with those true and false, or the free response ones, make sure that you understand so I gave you the answers to all of those. Make sure that you understand why the answers are the way they are. And if you don't understand that, then that would be a good thing to ask about. I don't think it's necessarily helpful to just like try to read through the documentation or something like that on your own, unless there's something you're particularly interested in. Instead, like use the questions that I gave you as a guide for what to look in the documentation, make sure that you can map the question to the documentation. Is that helpful at all?
Yeah,
a little bit.
I think
maybe.
you're like on some of the weeks you're like listed how like chapters or these parts of the documentation are responsible for the final. Like admittedly, I haven't been able to read all of them yet, and so I was wondering if like you would highly recommend just going back and reading those steps.
Yeah, that's a good question. I would say that you want to definitely make sure that you have, like, you know, sort of what the outline of all of those things are, so that like when you hit a question, you know, oh, these are the like 3 places that I might need to look at to make sure that I can reference the right spots. I think it would be good to read through them. I find them very interesting, but my guess is that that's not going to be like, my guess is that it would increase your grade, but that's like on the tail end of things to do in terms of focusing on the questions. I'd first focus on the questions that I gave you. Joey?
Let's see, where do we find the solutions to the questions that
Good question. So if you come back up here, let's see, I think, was it week 11? And yeah, the questions.pdf has the printout as I gave it to you. Questions.tech has the tech file that generated those solutions or generated the questions. And if you come down here, you can see in like the tech file itself, it has the labels of the answers right here. So if you don't want to print anything, you can just reference the tech file like this. If you did want to print it out,
What about the short answer part?
at the short answer stuff at the end. Yeah, I don't think there. Yeah, so in the tech file here, there's not answers listed. I don't have an answer key other than just the answers that I gave in class. If there's some that you have a question on, I'm happy to tell you what the answer is, but I don't have a key that you can just easily look at. Did that answer your question, Joey?
Yeah.
Good questions. Any other questions? So yeah, because like I gave you the answer to all of these questions, I'm not gonna like repeat this question exactly in the final, but good chance that like vast majority of questions will come the way I'll generate them is copy and paste one of these lines and then change a couple of the keywords inside of here so that the questions will be very closely related to the questions in this document. Any other questions about the final exam or anything else? When will the which homework? So the yeah, after you turn in or Monday we'll have class and we'll talk about the there's one last topic called async programming that the non-graduating students will have to do. The due date for that is the day of the scheduled final exam time for this class, which I believe is Wednesday of finals week. But that is not going to be like a super compute intensive task, and so yeah, no sort of extension on that. But you should have plenty of time on that. And so normal office hours times next week, and then during finals week, I will be available. I don't know exactly like when at this point. Anything else? Any other questions people have? All good questions so far. Okay, then the last thing is that you probably all got an email about course evals, so I would appreciate it if you take the time to complete those, and then yeah, the feedback. Again, this is the second time this course has been taught. I made a number of changes to it based on some of the feedback that people gave. And so whatever feedback you do give, yeah, I'll take that into consideration for future versions of this course. And so I would appreciate that. But yeah, with that, that's the last thing for today. happy to stick around and answer any questions that people have. And again, on Wednesday, I'm not going to sort of bring any material. I'll just answer whatever questions that people want to have answered. Okay.